In Algebra 2, Section 7.1, we're dealing with operations on functions. So basically, you've been dealing with factoring, equations, and polynomials, but now what we're going to do is we're going to start combining different functions together. In this case, it's just basic functions like we're adding, subtracting, multiplying, dividing, but then we're going to do a little bit something fancy at the end. The first one is sum, and the sum is pretty straightforward. I just need to add these equations together, f of x and g of x. And please pay attention to the order because it does matter on some of them, like difference. So I need f of x, which is 3x squared minus 2x plus 1, okay? And then g of x, and I'm adding here, x minus 4. So this is f of x, and this is g of x, right? So basically, I need to take this, whatever's in front here, and distribute it to my second equation. Since it's plus, nothing will change, but once I distribute it, I can get rid of these parentheses. So plus x, and then positive times a negative still gives me a negative. From here, all I need to do is just combine like terms. So 3x squared, and again, with these longer ones, you'll want to do it in this section constantly. You either want to underline or cross out if I've already used it. So in case I forget, I can go ahead and go back and include it. So there's no other 3x squared, so I have to bring it down. Now just x. Negative 2x and positive 1x gives me a negative x, or negative 1x, either way. And then positive 1 minus 4 gives me a negative 3. Now since none of these can be combined any further, this then becomes my answer. Right? Now difference is just the same, it's the same way, except in this case I'm going to be, there's going to be subtraction here, so it does change. So I'm going to start with f of x again. So 3x squared minus 2x plus 1, okay, minus x minus 4. I'm going to go ahead and take this and distribute it. So I end up with 3x squared minus 2x plus 1. Bring it all down, but get rid of the parentheses. And then a negative and a positive x gives me negative x. But two negatives gives me a positive 4. And just like this one, once I have gotten rid of those parentheses, I can combine like terms. There's no x squared, so I'm going to bring it down. Negative 2x and negative x gives me a negative 3x, and a positive 1 and a positive 4 gives me positive 5. And this is my answer. So that's sum and difference. So basically, once I distribute this last one, it just becomes combining like terms. Now we're going to try a little bit more. We're going to try a little bit more fancy ones, and we're going to go. Well, go ahead and pause that, write it down, you know, protocol, vocabulary. But now we're going to try a little bit more difficult, and we're going to do product and quotient, which is fancy terms for multiply and divide. And we're going to use the same equation. We're going to be multiplying here. G of x comes first, so g of x is x minus 4 times f of x, which is 3x squared minus 2x plus 1. Alright? So in this case, there's no plus or minus that we get rid of, but when we multiply two parentheses, what do we need to do? We need to distribute all the terms from here to every single term here. So I'm going to take this, and I'm going to multiply it to everything. So 3x times x squared is 3x to the third, times negative 2x, which gives me negative 2x squared, times positive 1, which gives me positive x. Yes? Then we're going to do the same thing with the entire second one, so that includes a negative. So negative 4 times 3x squared is negative 12x squared. Negative 4 times negative 2x is negative, oh, it's positive. Negative and negative make a positive 8x. And then negative 4 times positive 1 is negative 4. Alright? So again, what I did is I distributed every term. I did all the x's to all three, and then I did the negatives to all three. And then now I'm just going to go ahead and combine like terms. On this case, I don't have another cubed, So I'm going to go ahead and bring it down. 3x cubed. Now I'm going to look for the squared. I have a negative 2x squared and 12x squared. I don't seem to have any more, so I'm going to go ahead. Negative 2 minus 12 is negative 14x squared. My next one is going to be positive x plus 8x will give me positive 9x, and then minus 4. So since I can't simplify any further, this then becomes my answer. Right? My next one is quotient, which is division, and I'm going to divide g of x, which is x minus 4, over 3x squared minus 2x plus 1. Now in this case with quotient, what I want you to do is I just want you to see if you can divide it. Okay? If you, and remember how, and just see if you can simplify it. For example, if I'm going to put this into 2 fractions, then I'm going to go ahead, 2 bubbles. So if I have x minus 4, and I'm going to put this, remember, because there's a number here, I'm going to take this number and this number, I'm going to multiply it 3. Okay? And I'm going to go ahead and find 2 numbers. When added together gets me negative 2x. So I need positive 3 and I need negative 2x, so I can do negative 3 and negative 1. Nope, doesn't work. Let me see, negative 2 and 1. Oh, sorry, negative 3, positive 1 doesn't give me that. How about 3 and 1? No. And those are all our factors. We have no more factors. So that means this can't be reduced into 2 bubbles. This is as reduced as it can get. So because of that, this is then my answer. So what you do with quotient is basically to see if you can reduce it. If there's any common bubbles on top and common bubbles on the bottom, and if there's none, then your answer is just x minus 4. Because we tried all of these combinations and we couldn't get one that equals negative 2. So go ahead and pause and write this one too, and we have another one. So we've done addition, subtraction, we've done product, multiplication, and division. But now the next thing we have is composite. So basically the composite one is unique because it's basically one equation eating up another equation. I know it sounds weird, but that's basically what it is. We're going to do new equations here. And when you find a composite, basically all of the x's in the first letter equation is replaced by the entire equation of the second letter. So what that means is I have this 3x squared minus x plus 4. This is my first equation, yes? But instead of the x's, I'm going to put the g, the second one, into a bubble, okay? And I'm going to replace all of my x's with this bubble. So my equation looks like this. 3 of 2x minus 1 squared, because I have, again, my bubble there. So the entire thing goes in for x, minus 2x minus 1 plus 4. Right? And in order for me to do this, and we did a little bit of it, we did some of it in prior equations, if I have this, and there's a plus or minus in the middle, I can't just distribute that squared, but I need to put it into 2 bubbles. 2x minus 1 times 2x minus 1. And I have to FOIL. So 2x times 2x gives me 4x squared times minus 2x, right? And then minus 2x, and then plus 1. So my equation is 4x squared minus 4x plus 1. Yes, negative 2 and negative 2 gives me a negative 4x. So now, what I did here is I figured out this whole thing. So instead of this right here, I'm going to replace it with this bubble. So it looks like this. 3, and instead of this, I'm going to replace it with this again because I figured it out with it squared. So 4x squared minus 4x plus 1. And I'm going to bring everything else down. This has no square, there's no multiplication involved. So I do minus 2x minus 1 plus 4. So now I'm going to distribute, all right, this 3, and then after that I'll have no more parentheses. And again, I got rid of this parentheses because there's really, there's a negative 1 that I need to distribute. So I have this negative 1, and I'm going to distribute, so it becomes a negative 2x. And this negative 1 then distributes here, which becomes a positive 1. Don't forget that. So I've gotten rid of that parentheses. Now I have to get rid of this one by just distributing. So I have 12x squared, and go here, negative 12x, positive 3, and then bring everything else down. 2x plus 1 plus 4. And now from here, all I need to do is simplify. So do I have any x squared? No, this is my only one, so I'm going to write this down. 12x squared. Now let's look at the x's. I have a negative 12x and a negative 2x, which gives me a negative 14x. And then I have a 3 and a positive 1, which is positive 4, plus another positive 4, which is plus 8. And since I've underlined all of them, it means I used all of them, so this is then my answer. I know it's super confusing at first, but once you get this part set up and you do this, then it's just everything that we've been doing in the other section. And they'll ask for the opposite way, okay? And it's different answers. F of g of x is different from f of g of f of x, and what that means is that this equation is my original equation. So instead of this one being bubbled, I'm going to bubble this one and replace it with the x of the next one. So in this case, it's going to look like this. 2, and here's my x, so 3x squared minus x plus 4, and then minus 1. So this looks exactly like this again, but instead of an x, I have this equation. All right? So this one is actually a little easier because it doesn't have this square that we have to figure out. All I need to do is take this and just distribute it to each one. So 2 times 3 is 6x squared. 2 times negative x is minus 2x. And 2 times 4 is positive 8. And then I bring down the minus 1. From here I will combine my terms, but it looks like I have no terms, except these last ones that I'm going to turn down. So I'm going to bring 6x squared down, and negative 2x, and then 8 plus positive 8 minus 1 is plus 7, and this is then my answer. So if you understand this one, it's similar to this one, it's just this one so happens to have the squared, so it makes the process a lot longer, but it's about the same thing. And the last thing that you're going to be faced with is you're going to have an f, f of g or g of f, that's how you say it, that small circle's of, okay? But instead of an x in here, there's a number. Now this one is pretty, it's just like what you've seen before. I'm going to see which one. This is f of g. This is f of g. So basically it wants me to take this equation, do the exact same thing, but at the end, after I've replaced everything and solved everything and gotten to a simplified form, instead of an x, I need to actually have a number. So when I have a number in here, that means my answer is going to be a number. And I'm going to plug it in for all the x's. So I'm going to do everything I can, just makes the problem a little bit longer. Do everything I did, keep it the same, so 12x squared minus 14x plus 8. But this time I'm going to replace all these with 2, negative 2. Squared minus 14, negative 2 plus 8. Okay, this would be 12 times 4 minus, negative 14 minus 2 is positive 28 plus 8, right? 12 times 4 is 48 plus 28 plus 8. And I'm going to add and subtract from left or right. Okay, this is, oh, my brain is not working. Sorry, guys. 48 plus 28, 76 plus 8. Is that right? 48 plus 28. Yes. And then 76 plus 84, plus 8 is 84. Okay, so that's basically my answer. So this part, please don't forget it's connected to this entire part. So this is a continuation. Now if this had g of f, -2, then I would take this equation and replace all those with -2. So this is a pretty long section. I apologize for that, but we're going to do page 388, number 2 and 8. So go ahead and try that. Page 388, number 2 and 8, and I will see you in class.